So the last part of this section is where we're going to look at the idea of finding what is called a correlation coefficient and also a regression line. All right, so we're going to start with the idea of correlation, which we've already talked a little bit about in this section. So correlation, remember, tells us that there's a relationship between the variables. So when we're looking at this correlation coefficient that we're about to calculate, that is going to tell me two things. It's going to tell me, first, is there a relationship between the two variables? And then second, it's going to tell me what kind of relationship exists. So we know that we can answer those questions using a scatter plot. We saw that in the last presentation. We can also answer the questions using this calculation called a correlation coefficient, which we're about to look at. All right, so a couple of things that we should know about the correlation coefficient. Correlation coefficient can be any number between +1 and -1. All right, so now we're going to be using our calculator to calculate this value, this correlation coefficient. All right, the symbol that we use for correlation coefficient is going to be an R. All right, and so the calculator is going to tell you R is equal to, and it's going to give you a number between +1 and -1. And then we're going to use these three statements to kind of help us interpret. So we're going to look at that R value and we're going to ask ourselves, is it close to +1? In which case we're going to conclude that there's a positive linear relationship between the variables. Or maybe the R value is close to -1. We would conclude negative linear relationship. Or maybe the R value is not close to either one, it's kind of close to 0, in which case we conclude no relationship. Okay. All right, so before we look at an example, I just want to sort of tie that together with the scatter plots that we looked at in the last presentation. All right, so remember that an R value of 0, I'm going to start here in the middle, an R value of 0 means no relationship. So that means that your points should be scattered in a non-linear fashion, which means that the points do not make a line or even come close. Okay, no line. That means no relationship. That would be a correlation coefficient equal to 0. Okay. If your correlation coefficient is equal to -1, remember that the points should line up. Okay, now they may not line up perfectly, but they should show the pattern of a line. And in this case, the points are moving down. So we would have a negative linear relationship showing on that scatter plot and also from that correlation coefficient. All right, a correlation coefficient of +1, remember, says positive linear. So that means the points would be in a pattern of a line, maybe not an exact line, but we should be able to see that they're lining up. And it should move up from bottom left to top right. Okay, so there is that sort of relationship between the scatter plot and the correlation coefficient in that they should give you the same conclusion. Okay. All right, so I want to look at an example with you. All right, but before I do that, I want you to realize that to find the correlation coefficient, we are going to be using our calculator. And you will need to check with your instructor to see how to do that on your individual calculator. Not everybody has the same kind of calculator, so I'm not going to take time right now to show you how to do it on a calculator because you may have a different calculator. All right, but you need to find your instructor and make sure that you understand what buttons you need to push to get your calculator to calculate the correlation coefficient for you. Okay, so with that said, we're going to try part of this example. Okay, so it says a researcher wants to see whether there's a relationship between the number of hours a student spends studying and the score they make on the test. Okay, so we see the scatter plot. We also see the line. We'll get to the line in just a minute. But right now, we're going to look at the first part of this problem. The first part says, find the correlation coefficient. So I'm going to use my calculator. I'm going to enter the data into my calculator and tell my calculator to calculate the correlation coefficient, which remember is an R value. So when I do that, my calculator is going to tell me, I'm going to round it to 2 decimal places. So my calculator is going to tell me 0.92. Okay. Again, you're going to ask your instructor how to do that on your individual calculator. All right, once you know that, then you need to interpret what that means. All right, so this is where we're going to go back to these 3 statements, and we're going to say which one applies. So 0.92 is close to positive 1, right? So we're going to say that there is a positive linear relationship between these 2 variables. All right, so I'm going to write that right here. Positive linear relationship. Okay, so the next part of this problem says find the equation of the regression line. So we need to talk just a minute about what a regression line is and how we go about finding that. All right, so a regression line is a line that best fits the data. So if you look at the example on the screen, the data points have a linear pattern to them. Okay, they're lining up fairly well, but not perfectly. So it would be almost impossible for me to take a straight line and draw it through all of those points. But the regression line just simply does the best job that it can. Okay, so it may come in and it may be, like, look at it right here. It may be a little lower than some of the points and a little higher than some of the points, but we assume that things kind of balance out. The regression line, that red line on the graph, is the line that best fits the points. Okay, and then the purpose of that regression line is so that we can make predictions. Okay, so we can look at the data and we can say this is the trend. I'm going to use the regression line to make a prediction. All right, now the regression line is also something that you would calculate on your calculator. Okay, the formula for finding the regression line is very long and very tedious, so it is not something that you want to be calculating by hand. So again, you need to go to your instructor and find out on my particular calculator, how do I find the equation of the regression line? Okay, so coming back to my example, I'm going to go ahead and write it down for what I get on my calculator. All right, and it should be of this format: y is equal to, and I'm going to round my numbers to 2 decimal places, so 5.57, then it'll have an x, and then it's going to have it's an mx plus b format, so it's going to have a y-intercept. So 54.54. All right, so now I have the equation of my regression line from my calculator. And the last step says use that regression line to predict the exam score of a student who studies 4 hours. Okay, so what I'm going to do is I need to take this piece of information that they give me, and I need to look back up at my chart, and I need to determine that, hey, that's an X value. The hours that they spent studied, okay, you can see that on the X-axis on your scatter plot. We would normally have an X here to tell us that that's an X and that's a Y. Okay, but that number of hours studied is the X value. So what I'm going to do is I'm going to take my regression line, and where I have an X, I'm going to plug in the 4. And then I'm going to use my calculator to figure out what that's equal to. All right, so I get 76.82. All right, so that would be the predicted exam score for a student who studies 4 hours. Okay, so the purpose of this presentation is to give you an idea of how correlation and regression works. But you need to remember that both of those are calculated on the calculator. You need to ask your instructor to help you do the calculation on your calculator, and then you will be able to interpret the correlation coefficient using your 3 rules, and you will also be able to use your regression line to make a prediction about your data set.